It is not National Electrical Code compliant to tap into a branch circuit to obtain power for the current transformer unit and display. According to National Electrical Code Article 210.19, branch circuits shall not be tapped unless approved for the purpose. There are potential hazards with this approach. Firstly, there is the risk of overloading the circuit. Adding an additional load to the circuit could overload it, potentially causing a fire hazard. Secondly, it creates a safety hazard. It creates a condition where the current transformer unit and display are not properly protected by the branch circuit breaker. In case of a fault, the current transformer unit and display may not be disconnected, posing a safety risk. Thirdly, there are warranty issues. Tapping into a branch circuit may void the warranty of the electrical equipment. Here are alternative solutions. 1. Use a separate power source. Install a separate branch circuit to provide power to the current transformer unit and display. This ensures that it is properly protected and does not overload the existing circuit. 2. Use a power supply unit. Use a power supply unit that converts the available voltage, such as 240 volts or 480 volts, to the required 120 volts for the current transformer unit and display. 3. Use a current transformer meter with an internal power supply. Some current transformer meters have an internal power supply that eliminates the need for an external power source. For safety and National Electrical Code compliance, it is best to avoid tapping into the 20-amp 2-pole circuit breaker to obtain power for the current transformer unit and display. Utilize the alternative solutions provided to ensure a proper and compliant installation. Consider the ampacity of the conductors. Conductors must be sized appropriately for the load they will carry. Refer to National Electrical Code Table 310.16 for allowable ampacities of insulated conductors. Ensure that the conductors are rated for the voltage and temperature conditions of the installation. Overcurrent protection is also critical. Each circuit must be protected by an overcurrent device, such as a circuit breaker or fuse, sized to protect the conductors. The overcurrent device should interrupt the circuit in the event of an overload or short circuit. Grounding is also key for safety. All electrical equipment must be properly grounded to provide a path for fault current to return to the source. This helps to prevent electrical shock hazards. Bonding ensures that all metallic parts of the electrical system are connected together to create a low impedance path for fault current. This helps to prevent voltage differences between different parts of the system. Wiring methods must comply with the National Electrical Code. Conductors must be installed in approved raceways or cable assemblies. The wiring method should be appropriate for the environment in which it is installed. Junction boxes are used to provide a safe and convenient way to make connections between conductors. Junction boxes must be properly sized and installed according to the National Electrical Code. Conductor identification is crucial for safety and troubleshooting. Conductors must be properly identified by color coding or other means. This helps to prevent accidental contact with live conductors. National Electrical Code Article 110 provides general requirements for electrical installations. This article covers topics such as working space, guarding of live parts, and identification of disconnecting means. When selecting a separate power source, ensure that it is properly rated for the load it will serve. The power source should have sufficient capacity to supply the current transformer unit and display without overloading. A power supply unit can be used to convert a higher voltage to a lower voltage. Ensure that the power supply unit is properly rated for the load it will serve. The power supply unit should also be protected by an overcurrent device. A current transformer meter with an internal power supply eliminates the need for an external power source. This can simplify the installation and reduce the risk of electrical hazards. Select a current transformer meter that is suitable for the application. Consider the current range, accuracy, and output signal. Always consult the National Electrical Code and other applicable standards before performing any electrical work. Electrical work should only be performed by qualified individuals. Working on electrical systems can be dangerous if not done properly. Always take the necessary precautions to protect yourself from electrical shock hazards. When working on electrical equipment, always disconnect the power supply before starting work. Use appropriate personal protective equipment, such as gloves and safety glasses. Inspect electrical equipment regularly for signs of damage or wear. Repair or replace damaged equipment immediately. Keep electrical equipment clean and dry. Avoid exposing electrical equipment to moisture or corrosive substances. Follow the manufacturer's instructions for installation, operation, and maintenance of electrical equipment. Proper planning and preparation can help to ensure a safe and successful electrical installation. Take the time to gather the necessary information and materials before starting work. If you are not comfortable performing electrical work yourself, hire a qualified electrician. A qualified electrician has the training and experience to perform electrical work safely and in accordance with the National Electrical Code. Electrical safety is everyone's responsibility. By following the proper procedures and taking the necessary precautions, you can help to prevent electrical accidents. Always be aware of the potential hazards associated with electricity. Respect electricity and treat it with caution. Regular inspections and maintenance are essential for ensuring the continued safety and reliability of electrical systems. Schedule regular inspections to identify and correct any potential problems. Perform routine maintenance tasks such as tightening connections and cleaning equipment. Keep accurate records of all inspections and maintenance activities. National Electrical Code Article 90 provides an introduction to the National Electrical Code. This article covers the scope, purpose, and organization of the National Electrical Code. The National Electrical Code is a comprehensive set of standards for electrical installations. The National Electrical Code is updated every 3 years. The National Electrical Code is intended to protect people and property from electrical hazards. Always refer to the latest edition of the National Electrical Code. National Electrical Code Article 100 defines the terms used in the National Electrical Code. It is important to understand the definitions of these terms in order to properly apply the National Electrical Code. National Electrical Code Article 110 provides general requirements for electrical installations. National Electrical Code Article 200 covers the use and identification of grounded conductors. National Electrical Code Article 210 covers branch circuits. National Electrical Code Article 215 covers feeders. National Electrical Code Article 220 covers branch circuit, feeder, and service calculations. National Electrical Code Article 230 covers services. National Electrical Code Article 240 covers overcurrent protection. National Electrical Code Article 250 covers grounding and bonding. National Electrical Code Article 300 covers wiring methods. National Electrical Code Article 310 covers conductors for general wiring. National Electrical Code Article 314 covers outlet, device, pull and junction boxes, conduit bodies, fittings, and handheld enclosures. National Electrical Code Article 400 covers flexible cords and cables. National Electrical Code Article 408 covers switchboards, switchgear, and panel boards. National Electrical Code Article 430 covers motors, motor circuits, and controllers. National Electrical Code Article 440 covers air conditioning and refrigerating equipment. National Electrical Code Article 450 covers transformers. National Electrical Code Article 500 covers hazardous locations. National Electrical Code Article 505 covers zone classification of hazardous locations. National Electrical Code Article 517 covers healthcare facilities. National Electrical Code Article 520 covers theaters, audience areas of motion picture and television studios, and similar locations. National Electrical Code Article 547 covers agricultural buildings. National Electrical Code Article 550 covers mobile homes, manufactured homes, and mobile home parks. National Electrical Code Article 551 covers recreational vehicles and recreational vehicle parks. National Electrical Code Article 600 covers electric signs and outline lighting. National Electrical Code Article 604 covers manufactured wiring systems. National Electrical Code Article 605 covers office furnishings. National Electrical Code Article 610 covers cranes and hoists. National Electrical Code Article 620 covers elevators, dumbwaiters, escalators, moving walks, wheelchair lifts, and stairway chair lifts. National Electrical Code Article 625 covers electric vehicle charging systems. National Electrical Code Article 626 covers inter-system bonding termination. National Electrical Code Article 630 covers electric welders. National Electrical Code Article 640 covers audio signal processing, amplification, and reproduction equipment. National Electrical Code Article 645 covers information technology equipment. National Electrical Code Article 646 covers modular data centers. National Electrical Code Article 647 covers sensitive electronic equipment. National Electrical Code Article 660 covers X-ray equipment. National Electrical Code Article 665 covers induction and dielectric heating equipment. National Electrical Code Article 668 covers electrolytic cells. National Electrical Code Article 669 covers electroplating. National Electrical Code Article 670 covers industrial machinery. National Electrical Code Article 675 covers electrically driven or controlled irrigation machines. National Electrical Code Article 680 covers swimming pools, fountains, and similar installations. National Electrical Code Article 682 covers natural and artificially made bodies of water. National Electrical Code Article 685 covers integrated electrical systems. National Electrical Code Article 690 covers solar photovoltaic systems. National Electrical Code Article 691 covers large-scale photovoltaic electric supply stations. National Electrical Code Article 692 covers fuel cell systems. National Electrical Code Article 694 covers wind electric systems. National Electrical Code Article 700 covers emergency systems. National Electrical Code Article 701 covers legally required standby systems. National Electrical Code Article 702 covers optional standby systems. National Electrical Code Article 705 covers interconnected electric power production sources. National Electrical Code Article 708 covers critical operations power systems. National Electrical Code Article 710 covers over 600 volts nominal general. National Electrical Code Article 720 covers circuits and equipment operating at less than 50 volts. National Electrical Code Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. National Electrical Code Article 727 covers instrumentation tray cable type ITC. National Electrical Code Article 760 covers fire alarm systems. National Electrical Code Article 770 covers optical fiber cables and raceways. National Electrical Code Article 800 covers communications circuits. National Electrical Code Article 810 covers radio and television equipment. National Electrical Code Article 820 covers community antenna television and radio distribution systems. National Electrical Code Article 830 covers network-powered broadband communications systems. National Electrical Code Article 840 covers premises-powered broadband communications systems. National Electrical Code Article 900 covers tables and examples. The alternative solutions offer a compliant path for powering the current transformer unit and display. The first, which is using a separate power source, is the preferred method. This involves installing a dedicated branch circuit, ensuring that the current transformer unit and display have their own overcurrent protection and do not burden the existing 20 amp circuit. This adheres to the National Electrical Code's requirements for branch circuits and prevents potential overloads. The second alternative is using a power supply unit. This option involves converting a higher voltage, such as 240 volts or 480 volts, to the required 120 volts for the current transformer unit and display. It is essential to select a power supply unit that is appropriately rated for the load and includes overcurrent protection. This method also ensures that the current transformer unit and display are properly powered without tapping into the existing branch circuit. The third option involves using a current transformer meter with an internal power supply. These meters eliminate the need for an external power source, simplifying the installation and reducing the risk of national electrical code violations. However, it is crucial to select a meter that is suitable for this specific application, considering factors such as current range, accuracy, and output signal. Always consult the latest edition of the National Electrical Code and any other applicable standards before performing any electrical work. The electrical work should only be performed by qualified individuals to ensure safety and compliance. It is important to remember that electrical codes and regulations are designed to protect people and property from electrical hazards. Following these codes and regulations is essential for ensuring the safety of electrical installations.